So, what's the next big carbon capture technology of the future? As we see the transition from all the conventional carbon capture technologies like amine scrubbing and using pressure swing or temperature swings to using renewable electricity or electrochemical based approaches, I really believe that this supercapacitive swing adsorption, that is the use of supercapacitors to capture and concentrate carbon dioxide, is going to be one of the best technology of the future. So what is supercapacitive swing adsorption? As we see in this highlighted section, that it's a gas separation technology that uses reversible charging and discharging of supercapacitor to adsorb and desorb gases, particularly carbon dioxide. So why it is very selective to carbon dioxide is because carbon dioxide, when it gets in touch with the electrode and electrolyte, it has several different things going on. First, it hydrolyzes and gets converted to carbonate or bicarbonate ions depending on the pH. It dissolves. It is soluble in the double layer, and also it can adsorb to the pores of negative electrode inside the pores of negative electrode. So I would really like that all of you check how it works and how adsorption and desorption takes place, and what are the key benefits of supercapacitive swing adsorption compared to other technologies, and what are its current limitations. So I think any startup who would try to commercialize this, and I'm on to that, I really want that we commercialize this as soon as possible, would be the leader in the next $1 trillion carbon capture market. I would encourage that you guys also check all the research papers that is being published during the last few years around this field. Um, One of the most recent is from Professor Alexander Forsyth, I think, but it's not showing here. It's in a Journal of American Chemical Society. But one of the best one, which we're able to achieve very high uh, CO2 adsorption capacities, and we are able to demonstrate that this technology works in the presence of oxygen gas and other flue gas simulated mixtures, and this technology is able to survive thousands of more than thousands of hours of cyclic stability. Is one of this paper in Angwande Chemi, which is one of the most prestigious chemistry journal, which is right here. So I would recommend that you guys check this paper, in which we really go into the details of what's the history and how it all started, and how it's dominant basically compared to all the work that people are doing in top universities like MIT or others. um, and how our technology is able to electrostatically store large number of carbon dioxide molecules. It's just a figure. Then I go into the results and discussion, and mention few graphs on how we can adsorb and desorb carbon dioxide selectively and reversibly. And then there are some performance metrics. How is the energy consumption, how much carbon dioxide we can capture, what's the Faradic efficiency and energy efficiency. And here are some electrochemical details about first principles approach to understand the mechanism, the supercapacitive energy storage and carbon capture mechanism. Thanks.